So far with the programs that we've been writing, the variables that we've been using that need to affect the program have all been coded via our end on the programmer's end. For instance, in the last video, we had a circle that we wanted to find the area and the circumference of, and we manually had a float variable that we modified the value for. Now we probably want the user to be able to modify that and be able to change it every single time the program runs. We can do that in two different ways, so we can have them do it as they run the program or during the course of the run of the program. We'll address both of those here, and we will also try to go into using a library function, which is a function that has been written by somebody else. Here I've already written an example. What we're going to do is we're going to calculate e to the I theta from a command line argument, and then we'll also do it via reading straight in from the user during the course of the program. And we're going to get the theta and then calculate it. I'm not going to prove it here, but e to the I theta is equal to cosine theta plus I sine theta, which is a complex number. And because we don't have a complex data type in C++, I'm just going to print the real part, which is the cosine theta, and the imaginary part, which is the sine theta, separately. And we're going to need to use a library function in order to take cosine of theta and sine of theta. But before we actually go and take those, let's try to go through how to do command line arguments. In order to do that, what we're going to have to add to main is two arguments. So previously it looked something like this, where we had nothing. We hadn't taken anything in yet, but now if we want to get something from the user, we'll need two things, which will be an int called argc and a character pointer called argv. Now don't worry too much about what a character pointer is for now. We'll address that in a later course. What argc is the argument count. It tells you exactly how many arguments the user has given you when they ran the program, and argv will be the actual arguments that they've given. So it's an array, which we haven't gone into yet, that contains all of the arguments. Or it's similar to a vector in math in that it will contain a bunch of discrete values in each position, and we'll be able to get those. Now what I'm going to do is I'm going to see out these just so we can see them. I will see out the argument count first. And then let's see out two things. When we do the argument vector, which contains the actual arguments, then the first argument is going to be the name of the program that you're actually running. And that's going to be in the 0th position. The way we access things in a vector or in an array is using these square braces. So if I want to get the first thing in this array, I'm going to use 0 to grab the program name. So the first thing we're going to get should be the program name. I've forgotten something apparently. I forgot a semicolon. That should fix that. And then let's also print argv1. In this case, argv1 is going to be the angle of theta that we want here, and that's going to be given by the user. Now, in order to edit this in Visual Studio, you will need to edit the project settings, and we can do that either by right-clicking on the project over here and then going to Settings, or going to Project and then whatever the name of your project is. Mine's called Library Example Properties. You'll need to go to the Debugging tab here in Configuration Properties, and then you'll need to set command arguments. Make sure that you're setting it for the debug configuration. I, for whatever reason, had release earlier when I was trying to do this, and I want debug because that's the way I'm going to be running it now. Release is generally for when you want to build a full executable to hand out to people or a user base. Here we're going to enter our theta, so I'm just going to say 90 is probably a good angle for us to do because that's easy to check, right? Because the cosine of 90 is going to be 0 and the sine of 90 is going to be 1. Although it might be in radians, so that's probably not actually correct. Maybe I should do it as 3.14, but we'll worry about it later. Anyways, let's try to run the program now, and we should see that the argument count will be 2, and that we're going to get the program name and the angle that I just entered, and that's in fact what we see. The argument count will at bare minimum always be 1 because the first argument is always going to be the name of the program that you're running. You'll see here that argv0 is equal to this whole directory on my computer, and then finally the library example.exe that Visual Studio actually generated for me. argv1 is 90, which is what we expect because we just typed that in. So we can see that it actually got it. Now let's try to do this on Linux. I will copy this over, and I'm just going to need to overwrite it because I did try this earlier. I'm going to clear this, and we'll try to recompile. Yes, so this is in my CS135 directory. We will first compile it, and I'm going to do that with G++. One compiler command that I haven't gone over yet is the output flag. In order to do flags in Linux, it's dash and then the flag that you want. Here I'm going to do -o, which stands for output, and what I can use this for is to change the name of the program. Here I will just name it something like theta, and what this will do is the executable that the compiler is going to generate will now be called theta. It used to be called a.out, or at least that's what it calls by default, and that's what we've been using so far. But if you want to maybe generate multiple versions of an executable, or if you just for whatever reason don't like the name a.out, you can always set this -o flag in order to change the name of the output that it gives you. I think there's another way to do this, but this is the way I usually do it at least. After we put the output flag, we'll just want to give the name of the source file like we do normally. Here my name is library example.cpp. If I hit enter, it should compile, and if I hit ls, you'll see that we have a program called theta. The window's not resizing very well, but it should be somewhere around here. Ah, there it is, theta, and that's the program we just generated. Now, in order to run this, we'll need to do /theta as we normally do, / and then the name of the program to run it. And if we want a command line argument, the way we do that is we simply put the command argument directly afterwards. Here I'm going to do that with, let's just say 90 again, and you'll see that again we get an argument count of 2. Now the program name, rather than being that long string that was on my computer, it's just /theta because that's the command that was used to run it, and then 90 is the first argument. And if I wanted to change that, I could simply rerun the program, maybe type in 45, and now you'll see that the first argument is 45. This allows us to actually change the way that the program runs by simply setting variables before we run the program. Now we can also read in a variable over the course of the program, and the way we can do that is with something called cin. Whereas cout is the standard output, it's where we normally print things to or send output to, cin is where we're going to grab things from. Here I'm just going to do a prompt, so I'll put enter theta, and then whereas cout, we do the arrows facing it because we want to send things to cout. For cin, we're going to do an insertion operator, which is the arrows going the opposite direction because we want things to go from cin to us. Now, if I want to read, I need a variable to be able to read into. We want theta to be a float, so I'm going to create a float called theta, and then I'm just going to read into it. We simply put the variable name, and it will automatically figure out how that data type works, and it will read into it. If I have spaces or enters or something weird like that, it will automatically end the reading and not get that part. Here I will run the program, and you should see that we get enter theta, so it prompts me, and then it just kind of sits here and flashes, and the program doesn't finish running. That's because it's waiting for me to type in a theta here to read for that cin. So there's nothing in the buffer right now for it to read. Let's say I want it to read in 80. I'll simply type in 80 and then enter, and you'll see that I didn't print anything, so that was probably not very helpful. Let's cout this really quick. So I read, and then we'll put theta and then end line. Now we should see whatever I type in will get printed. I type in 80 and it says I read 80. cin is kind of nice because it will do any sort of parsing for you, whereas the other way I did it, everything is stored as a string beforehand. I will probably go further in detail on that in a future video, but for now we'll just roll with this. And just to demonstrate it on the Linux side, let's go ahead and copy this over. It's taking a second, there we go. We will recompile. I'll do G++. I'll do an output flag of theta again, and then it was library example.cpp. And if I want now, I can do ./theta. I don't need arguments anymore because I'm just using cin. So I can do ./theta, and it will say enter theta 40. Now let's just say I don't want to have to type that in every time, or for whatever reason I have 20 cins in a row. It would be kind of annoying every time you're doing your program to have to type that in every single time. And what we can do to get around that is we can simply use file indirection or file redirection to use a file to actually tell us what the input should be. Now the way I'm going to create a file is with a command I haven't given yet. In Linux you can use touch to update a file, and you can also use it to create a file. If I use this on an existing file, it will simply take the file and it will update its last open time to be right now. If you don't want to edit a file, but you want to update its metadata for its time, you can do it that way. You can also do it if you have a file that doesn't exist. So I don't have one called input example, hopefully. If I touch that, it will create a file. Now if I open that with Nano to edit it, you'll see that we get a completely empty file, but it does exist and I can now use it. What I'm going to do here is I'm going to type in what I want the program to read. In this case, we'll just say 36, and then I'll hit enter. And then I'm going to write this file, so I'll hit yes, and then enter. And you'll see that if I cat it to look at the file I just created, that it is indeed 36, and then an enter. Now the way I can use this file as an input to my program is I simply run it as normal, and then I give an arrow facing the program, and then the name of the file that I want it to read from. If I do this, you'll see that it skips the enter theta part, so there's no 36, it just automatically reads it from file straight into cin, or straight from cin, which is now a file instead of the terminal, and it says I read 36. So it's able to get it from a file. Now if we want to do the opposite here, where we, instead of reading from a file, we output to a file, we can do that as well. And instead of doing the forward arrow, we simply do an arrow away from the program. Here I'll do output example. You want to name this whatever file you want it to be named. I'll run it. You'll see I get nothing in the terminal now, but if I type ls, we have a file called output example somewhere, hopefully, right there. And if I look at the contents of this file called output example, it will be exactly what the program outputs. You can then use this to save information that you have from a run from a program. That way you can compare it with what you expect, or you can compare other runs, or you can just not clutter up your terminal if you want. Anyways, I think that about covers everything for reading in from the user. Let's go ahead and actually finish our program now. We have theta. I will delete this C out now. Let's go ahead and calculate the value. Now I could write sine and cosine on my own. I could do, an expanded Maclaurin series, or use some sort of table or something like that, but that seems a little bit annoying to write on our own every time, right? Especially for a small program like this. The way we're going to do this then is we're going to use code written by somebody else. That way we don't actually have to do it. We previously used IOStream, which contains cout. Another common library will be cmath, and if we want to include that, we'll simply do include cmath. Now what we'll do is we will simply print this, so I'll do the sine value. The way you do functions from libraries like this is you simply give the name of the function. Here we want the first function to be cosine of theta, so I'm going to say cosine should be the one from that library. You'll see that if you're using Visual Studio, it will actually suggest these for you. So we have like hyperbolic cosine here, and some other versions of these that are from CMath, and they take an argument of a double. Here, if I type this, you should see it will tell. I guess not. But cosine will take a double or a float. Either is okay. I'll simply type theta. The way you call a function in most programming languages is exactly the way that you use it in math. You simply give the name of the function. Here, the name of our function is cosine, and then any sort of arguments that you want to give to it. Here, that's theta, and then we put parentheses around it. So this will print the cosine part, and then we'll simply do plus I, and then I will print the sine part. Okay, and we will see if we run the program that it will ask us to enter theta as per usual. I'll say 90 because I think that's an easy one to work with, and we get it was in radians, so that's my mistake. Theta is in radians here, so we get presumably the value for cosine of 90 and the value of sine 90. And there you have it. Now we found e to the I theta. I could maybe even do something like this where I print that beforehand and say e to the I times theta equals, and then it will print that beforehand too. I don't think that is right. We'll just try to compile really quick. And maybe we'll try something like 3.14 since that's pi. We should get something pretty close. Yeah, so we get about -1, which is the cosine of pi, and then about 0, which is the sine of pi. And there we have it. So that's how we can get input from the user as well as use library functions written by other people.